Basic components of a Venn diagram. So let's begin our exploration of Venn diagrams. Welcome to this tutorial on the basic components of Venn diagrams. As you know, in mathematics, we often deal with collections of things, numbers, objects, or even other collections. These collections are called sets. Venn diagrams are a really powerful way to visualize these sets and, more importantly, to see how they relate to each other. Think of them as a picture that helps us understand set theory. Now, before we jump into more complicated things like finding the intersection or the union of sets, we'll get to those later. It's absolutely essential that you have a solid grasp of what makes up a Venn diagram. It's like building with Legos. You need to know what the individual bricks are before you can build a castle. In this tutorial, we're going to break down all those individual bricks or components of a Venn diagram step by step in a way that's clear and easy to follow. We'll start with the very basics and build our understanding from there. So, let's get started. Sets. So now that we've talked about what Venn diagrams are and how they help us visualize things, let's dive into the building blocks, what we call sets. This slide defines what a set actually is. A set is simply a collection of distinct objects, and we treat this collection as a single object itself. Think of it like gathering a bunch of items into a group. That group is now a single entity we can work with. Now, what can these objects be? Well, pretty much anything. They could be numbers, like we'll see in a moment. They could be letters, colors, shapes, or even other sets. Sets can contain other sets within them, which gets a little more advanced, but it's good to know it's possible. We usually use capital letters to name our sets. This just helps us keep track of everything. Let's look at some examples. Here we have A equals the set containing 1, 2, and 3. So, A is our set, and inside it we have those three numbers. We write it like this. The capital letter A, then an equals sign, then curly braces, those are like little brackets, and then we list the elements inside, separated by commas. So 1, 2, 3, and then we close the curly braces. Similarly, we have B equals the set containing a B and C. Again, B is the name of our set, and it contains those three letters. Notice how the elements within a set don't necessarily have to be numbers, they can be anything. Understanding sets is crucial because Venn diagrams are all about showing the relationships between these sets. In the next slide, we'll introduce the idea of the universal set, which provides the overall context for our diagrams. So, make sure you've got a good grasp of what a set is before we move on. The universal set. So let's move on to a really important concept for understanding Venn diagrams, the universal set. Now we've talked about sets, collections of things, but when we're working with sets and Venn diagrams, we need to define everything that's potentially under consideration. That's where the universal set comes in. The universal set, which we usually represent with a capital U, contains absolutely all the possible elements we're interested in for this particular problem. Think of it as the big box that holds everything we're going to talk about. Everything within our Venn diagram must be a part of this universal set. It sets the boundaries for our discussion. Let me give you an example to make it clearer. Imagine we're only interested in the numbers from 1 to 10. In this case, our universal set, U, would be the set containing 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So we would write that as U equals the set containing 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. It's crucial to define this up front. In the next slides, we'll see how these sets and the universal set are visually represented using circles within a rectangle. And understanding the universal set will help us correctly place all the elements and interpret the diagram accurately. So, make sure you grasp this concept before we move forward. Circles and sets. So let's move on to how we actually visualize these sets using a Venn diagram. This is where things start to become really clear. This slide is titled Circles and Sets, and it explains how we represent sets graphically. The first point here is quite straightforward. In a Venn diagram, each set is represented by a circle. Think of it as giving each group of objects its own little contained space. Now, crucially, the area inside that circle represents all the elements that belong to that specific set. So, everything contained within the boundary of the circle is considered a member of that set. Let's look at the example to make this concrete. We have two sets defined here. Set A, which contains the numbers 1, 2, and 3, and Set B, which contains the numbers 2, 3, and 4. Now imagine you're drawing this on a piece of paper. What we want to do is draw two circles. One circle will represent Set A, and the other will represent Set B, and here's a key point: these circles overlap. We'll talk more about why they overlap in the next slide, but for now, just visualize two circles intersecting each other. Voiceover. This overlapping part is important, as it visually suggests that there might be some elements that both sets have in common, which, as we'll see, is indeed the case with sets A and B. So, go ahead and sketch that out: two overlapping circles, one labeled A and the other labeled B. This is the basic structure of a Venn diagram with two sets, and it's the foundation for understanding more complex diagrams and set operations. Regions within the Venn diagram. Let's move on to slide 5. This slide really gets to the heart of why Venn diagrams are so useful. We're going to break down exactly what each part of the diagram means. First, let's look at different areas and their meanings. We've already drawn our circles representing sets A and B, and remember, we've got that rectangle around everything representing our universal set. You now notice where the circles overlap. The overlapping region, that's where things get interesting. This area doesn't represent elements unique to just one set, but rather, it represents the elements that are common to both sets. Think of it as the and part of a statement elements that are in A and in B. Next, we have the non-overlapping parts. These are the sections of each circle that don't overlap. These represent the elements that are unique to each individual set. So, the part of circle A that isn't overlapping contains elements that are in A but not in B, and vice versa for circle B. Finally, and this is a crucial one students often miss, the area outside the circles, but inside the universal set. This area contains all the elements that are part of our overall universal set, U, but aren't in either set A or set B. They don't share any characteristics with the sets we're specifically looking at in this diagram. Let's solidify this with an example. We're given three sets. A equals the set containing the numbers 1, 2, and 3. B equals the set containing the numbers 2, 3, and 4. And our universal set, U, contains the numbers 1 through 6. So let's apply what we just learned, looking at our example. The overlapping region, the part where circles A and B intersect, contains the numbers 2 and 3. Why? Because 2 and 3 are present in both set A and set B. Now, the non-overlapping part of circle A, that's the part of circle A that doesn't overlap with B, contains only the number 1. 1 is in set A, but it's not in set B. Similarly, the non-overlapping part of circle B contains the number 4. 4 is in set B, but not in set A. And lastly, the area outside both circles, inside U, everything within the rectangle but not within either circle, contains the numbers 5 and 6. These numbers are part of our universal set, but they aren't in set A and they aren't in set B. This slide is foundational. Understanding these regions is key to performing operations like unions and intersections, which we'll cover in future slides. So, make sure you really grasp what each area represents before we move on. Visual representation. Let's take a look at this slide. This is where everything really comes together visually. The slide asks us to imagine a diagram, and that's exactly what we're going to do. Picture a rectangle. Now, remember from our earlier discussion, this rectangle represents our universal set. We call it U. Think of U as everything we're considering in this particular problem. Inside this rectangle, we have two circles that are overlapping. Now, these circles represent our sets, A and B. Let's fill them in with the numbers we defined previously. The first circle, labeled A, contains the numbers 1, 2, and 3. So if you were drawing this, you'd write 1, 2, and 3 inside that circle. The second circle, labeled B, contains the numbers 2, 3, and 4. So you'd write 2, 3, and 4 inside that circle. Now notice where the circles overlap. This overlapping region is crucial. It contains the elements that are in both set A and set B. Looking at our numbers, the overlapping region contains 2 and 3. Finally, there's the area outside the circles, but still inside the rectangle. Remember, that rectangle is our universal set, U. This area represents elements that are in U, but are not in either set A or set B in our example. This area contains the numbers 5 and 6. So this diagram visually shows us everything: the universal set containing all possible elements, the individual sets A and B, the elements they have in common, and the elements that are not part of either set. This is the power of a Venn diagram. It gives us a clear, visual representation of these relationships. In the next slide, we'll summarize all these components, so make sure you have a good grasp of what we've covered here. It's the foundation for understanding more complex Venn diagram problems. Key takeaways. Let's recap everything we've learned about the basic components of Venn diagrams. This slide, titled Key Takeaways, is really important because it summarizes the core ideas we need to remember. First point, a Venn diagram uses circles to represent sets. Remember from earlier, a set is just a collection of things, and in a Venn diagram, we visually show these sets using circles. So, each circle stands for a specific group of items. Next, the universal set encompasses all elements under consideration. Think of the universal set, we often call it U, as the big box around everything we're interested in. It contains all the possible things we might be dealing with in a particular problem. It's the context for our sets. Moving on, overlapping regions represent common elements between sets. This is where things get interesting. When two circles overlap, that overlapping area shows us the elements that are present in both sets. These are the things they have in common. And finally, non-overlapping regions represent unique elements within each set. The parts of the circles that don't overlap show us the elements that are unique to each set, things that are only found in that particular set and nowhere else. Now, keep these points in mind, because on the next slide, we're going to talk about some common mistakes students make when working with Venn diagrams. Understanding these key takeaways will help you avoid those pitfalls and confidently tackle more complex problems involving set theory and Venn diagrams. Common mistakes. Let's move on to the final slide of this introductory tutorial on Venn diagrams. This slide highlights some common mistakes students make when working with these diagrams, and understanding these pitfalls now will save you a lot of frustration later on. So the title here is Common Mistakes. Let's break down each one. The first potential error is forgetting the universal set. Now, remember from earlier, the universal set, we denoted it as U, represents everything we're considering in a particular problem. It's the big picture, the boundary of our discussion. Students often leave this out when drawing their Venn diagrams, and that's a big mistake. It's like building a fence without defining the property line. Always define and represent your universal set, usually as a rectangle enclosing the circles representing your sets. It provides essential context. Next up is incorrectly placing elements. This is pretty straightforward. When you have your sets defined, and you know what elements belong in each, you need to be careful about where you put them in the Venn diagram. Think critically about whether an element belongs to set A, set B, both, or neither. Double-check your work. A small error in placement can completely change the outcome of your problem. Finally, we have not understanding the overlap. This is perhaps the most frequent source of confusion. The area where the circles intersect, that overlapping region, represents the elements that are in both sets. It's not elements that are similar to both, but elements that are actually members of both. So, if you're looking at set A and set B, the overlap contains only the things that are found in both A and B. Keep that crystal clear in your mind. Alright, that concludes our introduction to the basic components of Venn diagrams. We've covered sets, the universal set, how to represent them visually, the different regions within the diagram, and now, common mistakes to avoid. In the next stage, we'll start applying these concepts to solve more complex problems involving unions and intersections. But for now, make sure you're comfortable with everything we've covered today. Do you have any questions about any of these concepts before we move on?